So finding direction now. So we're going to have to keep in mind that with direction, we're looking at theta, we're looking at tangent, etc. So remember, your opposite and adjacent is your tangent. So in terms of where we're going with this, how does this relate to whatever we're talking about? Your x component is your adjacent, your y component is your opposite. So keep that in mind. So an archaeologist climbs the Great Pyramid in Giza. What is the magnitude and directions of his displacement? So we're going to make this r because we're trying to find the resultant, if you will. I'll use the black color for that. So we're trying to find the resultant. Here to here. Not the best drawing, but I apologize. So what is the magnitude and direction? So magnitude means you have a number and you also need a unit. So our units are going to be in meters. So what are we going to do? We got to use our Pythagorean theorem first. R squared equals my x component and the y component. But remember, you have to square those. So it's 115 squared plus 136 squared. So r equals the square root of 115 squared plus 136 squared. R equals so we end up with 178.1039, so should be 178 meters. That's the r, the resultant vector. Now I got to find the direction. So direction is, use a color. So tangent, so inverse tangent, and then I got to plug in, remember, it's my opposite over my adjacent, so katoa. So that means it's going to be the tangent, inverse tangent of, so theta equals inverse tangent of 136 divided by 115. So approximately, let's put these to the nearest whole number for our angles. So I got 49.78, blah, blah, blah. So this is going to be 50 degrees. So my answer, when I'm done with this, the final answer will be, let's see, 178 meters at 50 degrees. And that's okay. That's all I'm expecting. I'm expecting you to do the Pythagorean theorem for this and also do the, I guess I don't know how I got missing, the tangent or inverse tangent to get your angle. So what is a plane travels from Houston to Washington, D.C., which is 1,540 kilometers east and 1,160 kilometers north of Houston. What is the total displacement of the plane? I'm looking for a magnitude, a unit, and a direction. So first you're going to draw your crudely but still nicely drawn diagram. Let's make our compass north, south, west, east, so we can kind of keep in mind where we're going. So we are going, a plane is traveling 15, so let's go east. So we'll make this 154 kilometers east, and we are going north. (1,160 kilometers). What is the total displacement? So I'm trying to find r. I'm trying to find I'm trying to find the direction, which I'm going to use with the angle. And this is all a right angle like that. So that means I can use my Pythagorean theorem and tangent and all that. So R equals R squared. I keep on doing that. R squared equals your v component squared plus your y component, y velocity component or vector component squared. R equals square root of my x component squared, so 1,540 squared plus 1,160 squared. R equals 1,540 squared plus 1,160 squared. The answer I got was 1928.00 blah blah blah. So my my magnitude in unit will actually be 1,928 kilometers. I got to find my angle. To find your angle, you're going to use your tangent, inverse tangent. So theta equals inverse tangent of, so it's opposite of the angle. So that's 1,160 divided by 1540. So inverse tangent 1,160 divided by 1,540. Your angle that you end up with 36.9887. So that's approximately 37 degrees. So my final answer will be, what's the total displacement? It is 1,928 kilometers at 37 degrees. And that's fine.